All right, let's talk about a coder's secret weapon. Today we're diving into one of the most powerful, yet simple concepts out there, the stack. We're going to see how this one little idea is the key to cracking some seriously tough problems.
So let's start with something you probably do a dozen times a day. You're typing. You make a mistake, and what do? You hit Control-Z, and bam, your last action is gone. But have you ever stopped to wonder how your computer actually knows what your last action was? Well, the answer is a beautifully simple data structure called a stack.
You know, the easiest way to wrap your head around a stack is to just picture a stack of plates, maybe in a cafeteria line. You can't just yank a plate out from the middle, can you? Of course not. The whole thing would crash down. You can only put a new plate on top, and you can only take a plate from the top. That one simple rule, that's everything. And this brilliant idea has an official name: last in, first out, or LIFO for short. The very last plate you put on the stack is always the very first one you take off. Seriously, if you remember nothing else from this, remember LIFO. It's the heart and soul of the stack. Okay, so that's the big idea. Now, let's get just a little more formal with this plate stacking rule and really unlock what makes this data structure so powerful. The crucial thing to get here is that a stack is all about control. Think about a regular list or an array. You can grab any element from anywhere at any time. A stack is totally different. It forces you to follow a strict order with only one way in and one way out, right at the top. Now, to actually use a stack, you only need to know 3 basic moves. Just think of them as the only 3 things you're allowed to do with that pile of plates: push, pop, and peek. First up is push. This is as simple as it sounds. It's just the action of adding a new item, our new plate, right onto the top of the stack. That new item is now the last in item. That's it. And the opposite of push? Well, that's pop. When you pop the stack, you remove the element that's sitting on the very top. This is how you get things out of the stack. And remember, you can only ever remove the one that was added last.
So let's just put them side by side to make it crystal clear. Push adds to the top, pop removes from the top. They're like 2 sides of the same coin, the 2 main actions that define exactly how a stack behaves. In and out, always from the same spot.
Okay, but what if you just want to see what's on the top plate without actually taking it away? That's where our third move, peek, comes in. It lets you just take a look at the top element, but it leaves the stack exactly as it was. It's like a sneak peek without messing anything up. All right, I know this might all seem a little abstract, a bit theoretical, so let's connect it to the real world because you are using stacks constantly, whether you're browsing the web or writing code. I mean, look at this list. What's so amazing is how many everyday things run on this simple LIFO principle. The undo feature we talked about, your browser's back button, even the fundamental way that programming languages keep track of which function is running, it is all powered by stacks, working quietly behind the scenes.
Let's just walk through that browser history example real quick. Imagine you open your browser and go to Site A. In the background, your browser pushes Site A onto its history stack.
Then, from Site A, you see an interesting link and click on it, landing you on Site B. What does the browser do? It pushes Site B right on top of the stack. Now the stack has both sites, and B is the newest one, the last one in. And now for the magic. You hit the back button. What's really happening under the hood? Your browser performs a pop operation. It removes Site B, the last thing you added, and suddenly the new top of the stack is Site A, which is exactly where you land. It's so simple, but so elegant. So, beyond these everyday features, the stack is a seriously powerful tool for solving some pretty complex logic puzzles, especially when you're coding. For example, here's a classic problem. How can you write a piece of code to check if all the parentheses, brackets, and braces in a string are correctly matched up and closed? It looks complicated, right? But with a stack, it becomes almost trivial. So check this out. Here's the logic. As we read the string from left to right, anytime we hit an opening bracket, like that first open parenthesis, we just push it onto our stack. Then, when we hit a closing bracket, we peek at the top of the stack. If it's the matching opener, we just pop it off. We keep doing that, and if we get to the end and our stack is empty, boom, we know the expression is perfectly balanced.
Now, because of this incredible problem-solving ability, getting a handle on stacks isn't just an academic exercise. It is an absolutely critical part of any programmer's playbook, especially when you're heading into technical interviews.
And here it is. This is the golden rule you need to burn into your brain. When you're faced with a coding challenge, look for these trigger words:
If you see phrases like undo, previous, or that valid parentheses problem we just solved, a little alarm should go off in your head that screams, think stack.
And I'm not just making this up. These are some of the most common, most classic questions that get asked in software engineering interviews. If you can master the stack, you have a direct line to solving all of these problems efficiently.
And why is it so beloved in interviews? Because it is unbelievably fast. The main operations, push, pop, and peek, are all what we call constant time, or O of 1. In plain English, that just means it takes the same amount of time to pop an item whether your stack has 10 elements or 10 million. That kind of efficiency is a massive, massive win.
So if the plate analogy doesn't quite work for you, here's one more mental model to lock this in. Just think of a stack like a narrow, vertical pipe. You can drop things in from the top, and you can pull things out from the top, but you can never, ever reach into the middle to grab something.
You know, when it comes down to it, the stack is just a beautiful example of how a very, very simple rule, last in, first out, can be used to build elegant solutions for some surprisingly complicated problems. So the real question is, now that you get it, what puzzle are you going to go out and solve?